Hello and welcome to Full Tech Ahead. This is Amanda Razzani, and I'm happy to be here today with Robert Dahlstrom. He is the founder and CEO of Apellix.
Good morning. I am thrilled to be here. Thank you for inviting me.
Happy to have you on the show. Can you share a little bit about your background and what led you to the company?
Yeah, it's actually an interesting origin story here. So Apellix is the second company I founded. My first company was an internet security software company. And I tell people that the drone company, Apellix, is also a software company because without software, the drone is just a brick. It doesn't do much of anything. So the software is what makes it special, what makes it magical, what makes it do the amazing things that it's able to do out there in the world. So basically how this came about is I used to paint houses working my way through college. And my wife and I had a beach house that needed painting, and it's, you drive under and then it's 2 stories. So it's kind of tall. And I got some prices and I'm like, wow, it's really expensive to paint. And I had time. So I'm like, I can do this. So I had the scaffolding delivered and I'm on a ladder on top of the scaffolding. I'm up there spray painting and I'm like, man, I'm not in college anymore. And I thought, drones with software, keep them the right distance from the wall and paint. And then I'm like, no, paint is really heavy. Battery life is limited on drones. You'd have to constantly land and add batteries and add new paint. And I looked down on the ground and the compressor was on the ground, the paint compressor. I'm like, eureka, keep the paint on the ground, the paint compressor on the ground, the power on the ground, bring everything up a hose and an umbilical cord, tether to, and then with software, control the drone to keep it the right distance from the wall to paint. So I went home, built a prototype in my garage that actually worked better than I thought I would. And then I kind of went heads down into to starting the company.
That's absolutely incredible. First of all, that you took the initiative to paint your own house. I really applaud that. But then the fact that you could actually build this and use it and it worked, that's really awesome.
Well, the first versions, of course, they worked, but they weren't perfect and they weren't ready for the market or anything like that. They were a lot of duct tape and even things like pool noodles and tomato cages for the landing gear, because if you landed too hard, they'd crumple and then you just stretch them back out. I mean, it was all just proof of concept stuff back then, but it worked well enough that, with just a 1-page website and a 1-page press release, we started getting calls from the largest coating manufacturers in the world, a lot of industry that maritime or industrial or oil and gas that were interested in this technology because it just solves a lot of issues that are out there in the coatings and painting industry.
So now tell me more about what you're doing now. So you started there, but I was just at the Energy, Drone, and Robotics conference where you had a booth, and I saw all kinds of use cases from power washing, painting. Share everything you're focused on now.
Yes. So the initial idea for a painting drone is just now coming to fruition 10 years later. So there's been 10 years of development to get that to the market. So before we launched the painting drone, we launched the power wash drone. That doesn't require the same amount of precision. Generally, you're 4 meters or so away from a surface, blasting water on it at high pressure. So if you're a couple inches off on your flight, it's not a big deal. If you're painting and you're 14 inches from the structure and you're a couple inches off, it is a big deal. So I tell people developing the spray painting drone in some respects is a lot harder than self-driving cars. Self-driving car, you tell it to stop, it stops. You tell a drone to stop, it falls out of the air. A self-driving car is successful if it doesn't run into something or collide to something. It doesn't have that level of precision that you've got to have when you're applying paint. So we've done all the things that have been difficult, all the science that's difficult to enable our aerial robotic systems to paint, because there's 3 things a drone needs to fly safely. One, it needs to know where in the world it is. It gets that from the satellites, GPS. Well, when you're in a tank farm surrounded by tanks or in a canyon, urban canyon surrounded by buildings and you can't see the satellites, you lose that. The second thing a drone needs to fly safely is where in the world it is, which direction is it headed? And that's magnetic compass. Well, a big piece of steel, big piece of metal says, hey, I'm north. And so as you get close to infrastructure, it doesn't know which direction it's going. And then the third thing, just like airplanes, it needs to know how high off the ground it is. It uses barometric pressure. When you get closer to walls and structure, their barometric pressure readings are gone or wrong. So everything that a drone requires to fly safely works really well when you're out in the open sky. But when you get close to structures, it doesn't work. So we've had to spend a lot of time and work and energy and money and development into augmenting those systems so that they do work, and they rely on our sensors we've added to the drone to be able to code. So it's been a long development to get there with the painting drone, and it is in field trials now, which is exciting. But along the way, we did launch the Power Wash drone, and that was an immediate hit. At this point, we're in 21 countries around the world. It's amazing. I wake up in the morning, I'll see some social media page where our customers are going out and doing just phenomenal things with these drones. And the benefits are great because, you know, it's faster, safer, cheaper. There's no one at lift, so they're not at risk of falling. It's just a lot of positives for this industry with the drone use.
Yes. Tell me about some of the industries that are using this technology. Can you share some of the companies or some use cases?
Yeah. So because we're a manufacturer, we sell these, right? And then our users take them out and do work. But in addition to that, on occasion, and as part of our development, we do work with different companies. So with the painting drone, for example, we've partnered with Graco. We've partnered with Akzo Nobel and International Paints. We've done some partnering with Sharon Williams Specialty Coatings divisions. So we do jobs there as part of our field services group to learn and to innovate and make the product better. But some of the amazing things we've done is we've been in active oil and gas refineries, taking thickness measurements on the thickness of steel and the thickness of paint with our autonomous drone that flies up and makes contact with the structure. And this is in what's known as Class 1 Div 2 hazardous locations where there's potential flammable combustible material in the air. So it's just amazing. We've been places like that. We've been places like shipyards where they're building the aircraft carriers and the destroyers and doing work there where we're measuring the thickness of paint on the side of these warships. And then we've done things like where we go consult with the Space Needle in Seattle on how to clean it with a drone and how to pressure wash it with drones. So that added to the things that our customers do is just amazing. And more verticals are opening up. So not only is this used in like oil and gas, but even like energy infrastructure. We're now working with one of the power transmission line owners to clean the insulators on power transmission lines with the drone. Right now, they're doing it with a helicopter. So the value proposition on these applications is just huge. In addition to the safety factor that, you know, you're not at risk because you always have your feet on the ground. The drone's up there in the air doing the actual work.
Yeah, absolutely. Preventing many accidents, I imagine.
Yeah. And we've even done things like we did a case study with the city of Wooster, Ohio, right? They have an elevated water tower out there. And we did it. Half the cleaning was done with the drone. Half the cleaning was done the conventional way with a lift and people up there on pressure washers. And then the coatings company inspected it and said, yes, both sides are equally clean. But then the kicker was you just extended the life of the coating 4 to 5 years. So to paint one of those elevated water towers is like $750,000. Wow. And they typically have a 30-year lifespan. So that's $15,000 a year, basically. So, or $5,000 a year. So anyhow, you multiply that times 4 years, you've just saved that municipality, $100,000 basically, because it's $25,000 a year. So because they don't have to paint it as soon. So by keeping it clean, there's just a huge amount of economic benefits to public infrastructure, to the private infrastructure, to hotels, hospitals, anything around the world. We've got mines that are using this in South Africa. We've got dairy farms that are using it to keep their big containers clean, even food manufacturing places, just all over the world. And it's quite amazing. We have one company in Israel that was cleaning 20 years of coal ash off the roof of a structure. And it was like this deep. It was like 12 inches thick. And I'm like, that's the wrong tool for the job. You should not be cleaning that with a drone. That's going to take you forever. And they're like, no, Bob, you don't understand. That is the only way we can clean that. Because it's a 20-year-old roof, we can't walk on it because we don't know the structural integrity underneath it. So the safety people wouldn't allow that. Because it's where it's physically located, there's no way to get a lift with an articulating arm long enough to get to where that roof section is to clean it off. So their only other option was to bring in a 180-foot crane and have somebody in a basket hanging from the crane power washing the roof. And the safety department said, no, you can't do that. That's why it hadn't been cleaned in 20 years. But they were up there blasting those big chunks down into smaller chunks and smaller chunks and smaller chunks and washing them over the edge with the power washing drone. So it does things that historically have been impossible or difficult to do. And one of the advantages, because it is small and mobile, is it doesn't really care about complicated geometry. If you're trying to scaffold something or bring in a lift or bring in a crane and you've got a complicated geometric structure, it takes a lot of moving things around to be able to get people at elevation to clean those things or to pressure wash them or to paint them, right? But the drone doesn't care. It can fly around complicated geometries very simply and easily.
Wow. So the return on investment is not just monetarily, it's time, efficiency, and safety all.
Yeah, exactly.
What is the size of the drones, or do they come in different sizes?
So they're all about the same size, the ones we make at Apellix. They're all built for the 55-pound weight classification by the FAA. So once you start lifting over 55 pounds, you have to get special waivers or exemptions to do that. If you stay under 55 pounds, all that's required is a drone pilot's license. And flying within the regulations, obviously. So that enables us to power wash up to 194 or 197 feet using a standard hose, which is 31 feet higher than some of our other competitors can do with the same hose, because our drone is the lightest, most powerful drone in that 55-pound category. But they are pretty beefy, right? They're about a meter by a meter, so about 36 inches. But there are 8 motors on them, so 4 arms. So, a lot of what our engineering has done is we've built the safest drone possible. And by having 8 motors and 4 arms, if one motor goes out for some reason, you're still able to safely fly the drone and land it because you've got redundancy there. That's also part of what makes it so powerful, is having those 8 motors. But it folds down; those arms they push in and fold down, and it goes inside of a 24-inch cube. So you've got a 26-inch Pelican case that it goes inside of for transport. So they are pretty easy to get to a job site and pop open the arms and connect your water to it or your paint to it, and boom, you're up and running.
Wow, that's impressive. So are you sitting behind a computer piloting this drone? You said it's autonomous, but do you have to program and watch where it's going?
There are different levels of autonomy depending on the drone. So the power wash drone is basically 100% manually flown. Now, there is some autonomy on there that will hold it the right distance from the wall. Like if you want to set it to clean the side of a building and you want to be 2 meters, 4 meters, 6 meters away, there are settings on there that you do so that you never get closer than that. The painting drone has much more autonomy in it. The painting drone is maintaining the distance. It's locked in the distance from the structure so that it's not varying. It's locked in the perpendicularity so that it's pointing to the structure. It's not pointing to the left or the right. And it's locked in the speed at which it travels. So it's also using the computer to turn on and off the paint. You don't manually do that. So there's a more a lot more autonomy built into the painting drone. And then moving both those platforms forwards towards full autonomy is the work we're doing with the U.S. Army. So we have a small contract with the Army for chemical, biological, radiological, and nuclear defense. So that's CBRN defense. So in the event that somebody drops a chemical warfare, right? They drop a biological agent. Right now, it can take the Army 10 hours or days to clean their assets and get them back in service. We are working with them in a way to do it within 10 minutes. And we're working such that it's autonomous. So right now, our proof of concept with that, the drone pops up, looks around, locates the target, flies to the target, does a mapping of the target, and then figures out how to turn on the water to clean it, to rinse it off. Then the next component is it'll be scanned, and they'll determine where there's any biological agents or chemical agents. And then the third component would be we would then go and spray and encapsulate and or paint over the paint that neutralize the decontamination agents and neutralize it. And what's beautiful about that is that's all done autonomously without a soldier being present, so that the soldiers are safe and out of harm's way. But it's a dual use technology, meaning everything we develop for the U.S. Army is also being made available to the general market. So you can see where we're going as we develop this for the Army. We'll be adding that capability to all of our platforms, painting, cleaning, non-destructive testing as well, so that the drones are all autonomous.
That's wonderful. So what's next? Do you have any next solution you're trying to solve that you can share a little bit about?
Absolutely. So one of the things is, so we built the reason we're launching the spray painting drone now is the pressure washing drone is built on an amazing platform that's in use in 21 countries around the world by hundreds of companies, and it's got tens of thousands of flight hours on it. And it is a remarkably stable platform. So that gave us the technology we needed for the spray painting drone to be able to launch it on a rock solid, battle hardened platform. And so now that we have that platform, we're able to launch the painting drone. So the painting drone is doing traditional, what's called airless paint spray painting. So that's when you see people spray painting. 99% of the time, they're going to be spray painting traditional airless paint spray systems. There are also specialty coatings. There's just an amazing amount of technology that's gone into the coatings field over the last couple decades. And things like nanotechnologies have come along, and there's a coating out there is developed by NASA, and it actually, you spray it on something and it pulls carbon monoxide and nitrous oxide out of the air. And those are the two main components for smog. So this actually cleans the air. And the scientific studies they've done with this, where they've done coatings of like city streets, where they've coated the buildings with this, and then they measure the amount of pollution in the area, and it significantly takes pollution out of the air. And it's activated by sunlight, and the pollution sticks to the wall, and then it just rinses off when it rains. So and it turns it into water and salt most likely. So not getting too scientific, basically water and salt. So what we want to do is we want to apply that to be able to clean the air. So think of all the sound walls on the side of the interstates. There are thousands and thousands of miles of that. If we apply this specialty coating to those sound walls, we can drop pollution. And there are hundreds of thousands of deaths around the world every year due to pollution, air pollution, where people are breathing, things that is not good for them. And so by reducing pollution, that's just air pollution. That's one more way we can use this drone technology to make the world a better and safer place. Now, to get there is going to be time, money, and development, because it is a nanotechnology, and it does require specialty technology to apply it. HPLV, high pressure, low volume system versus an airless paint spray system. But now that we've got the airless paint spray system locked down to where it is so precise that it's able to apply coatings that are measured like here. This that I'm holding up is called a Q panel or a coupon. It's a piece of metal. When you spray it, you take it down and then you measure the thickness of the paint as well as getting a visual to how well the coating was. And this is a specialty coating we put on here that you encapsulate over corrosion. It's used by the oil and gas companies offshore and onshore as well. And then it's measured in mils. A mil is a thousandth of an inch. So this one right here is 7.4 mils thick. So being able with our current system to be able to lay down a film of coatings and to the manufacturer's specification within 20% of their definition of what a good coating is just a world-changing, remarkable achievement. And having that with the airless paint spray system enables us to then go spend that development money, take that time, and put that other paint system on so that we can start applying these nano coatings, these more exotic coatings, the things that pull the pollution out of the air or do some of the other amazing things that some of these coatings do.
This is absolutely amazing information. Thank you so much for coming on the show and sharing all this with us today.
Oh, my pleasure. Thank you.
Is there anything else you can add?
Well, I could drone on for hours about this. But no, I want to give my heartfelt appreciation for you providing the platform and allowing me to talk about this. But it is obviously something that's near and dear to my heart and very exciting. And it is something that I believe can save lives. And so I'm very fortunate to have so many amazing people here at Apellix working on this project. It's like I'm not worthy. The staff here, the people here that are working with Apellix, the people that contact Apellix with ideas of how to move things forward in the corrosion industry or elsewhere are just phenomenal people. And I'm just very blessed to be spearheading this effort at this time.
Absolutely. I think it's just amazing. All of the use cases, again, that I saw at that Energy, Drone, and Robotics Summit in Houston, very fascinating. What the impact on the world is just remarkable.
Yeah, I gave a speech to the International Window Cleaners Association this year, and one of the members in the audience, his father was a window cleaner, and he fell and died. And so I'm like, this is 2025. Why are there still people hanging on ropes off the side of buildings or on lifts cleaning or painting if we have drones that can do that, if we have robotic systems that can do that? So that's my mission, is to push this into the world and get people down off of elevation, put their feet on the ground where they're safe, have the robots out there doing the work instead.
Absolutely. Well, that's a great mission. Thanks again for coming on our show. And I want to thank our audience. Stay tuned. There's more podcasts like this on the way.